So my name is Kevin John. It's been my pleasure to be the subject matter expert for Benjamin Snyder. He's been working on a payload that we developed previously for another project. And this is the first time that we've tried to have people develop and build that payload remotely. So there've been many challenges to overcome, but as anyone familiar with engineering will tell you, the ability to push through a problem even when it's not working is, one of the best predictors of success for science, technology, engineering. And it's been really great for me to be able to have those kind of vicarious moments of success where something that something you've been working on for a long time that hasn't been working finally works. It's a great feeling. And it's great for me to be able to experience that, even via email remotely. So without further ado, let me turn things over to Ben and he can tell you about the project he's been working on.
Hello, I'm Benjamin Snyder, and I am working on this project, or have been working on this project since June. This is my rocket and payload. This is the Rising Data Flight Project by Benjamin Snyder, N3 Internship Program, September 10th, 2021. Project objective: launch a model rocket with an Arduino-based payload equipped with a SparkFun 9 degrees of freedom sensor stick and a temperature sensor to collect. 9 distinct types of motion-related data, 3 degrees each of acceleration, magnetic orientation, and angular velocity, rotational motion, ambient temperature. Build a model rocket to support a payload for data collection. Construct an Arduino-based payload for the model rocket consisting of custom proto board, Arduino Pro Trinket 3-volt, micro SD card device, 9DOF device, TMP36. Launch the rocket to collect data to analyze the flight, to be scheduled with the Southeast Alabama Rocketry Society. Proto boards, custom designed boards for rising data payload components. Did you know for Dr. Kaminsky that using the same proto board to build a battery board saved money by not having to print another design? Arduino Pro Trinket 3-volt. What it does, provides the processing power for the payload, runs Arduino C processing code written with Arduino Integrated Development Environment, IDE. Problems encountered, kept getting error, could not upload to the board. Troubleshooting, things confirmed corrected during troubleshooting process. Used multimeter to confirm the voltage between the ground and power rails was 3 volts. Confirmed FTDI version of the Adafruit board was selected. Confirmed correct port selected. Under programmer option, set to USB Tiny ISP. Reloaded Adafruit driver. Update drivers for the FDTI cable. A small embed processor known as the UART. Confirmed USB serial port properties. Conclusion: Pro Trinket board defective. New one sent and worked. Micro SD card device. Connects Arduino board over an SPI bus. Supports writing of data collected to a text file on the card. Problems encountered. Error: initializing SD card. Card failure not present. Got it to work intermittently a few times where it wrote to the card. Troubleshooting. Continuity testing with multimeter. Thank you, Mr. John, for visuals. Reformatted the card with FAT32. Tried another SD card. Tried 4 GB PNY card and 8 GB SanDisk. Updated version of SD library version 1.2.4. Checked voltage, all measured 3 volts. SD card seems okay. Can write to it. Possible that SD board is bad. 9 degrees of freedom board. Has 3 sub-sensors that collect telemetry during flight. Communicates with Arduino over an integrated circuit I2C interface. Combines a 3D accelerometer, a 3D gyroscope, and a 3D magnetometer into a single device that outputs 3 key properties of movement. Captures 9 distinct types of motion and orientation related data. 3 degrees each of acceleration, or the rate of change of velocity, GG forces, based on pool of gravity, rotation, degrees per second, and magnetic field, Gauss, gathered the acceleration, gyrosensor, and magnetometer. Problems encountered. Misplaced the 9DOF on the proto board. Adjusted wiring to compensate when 9DOF board was inserted. The light's power still went out on the Arduino board. Code issues: did not have SparkFun LSM 9DS1 IMU library for 9DOF sensor board installed. Some coding errors. Troubleshooting: continuity checks found a wiring issue that was likely causing power problem. Removed all 9DOF wiring in a socket and did over, corrected power problem, corrected the code. Thank you, Mr. John. It worked. Can't see output in serial monitor because SD board is not functioning. TMP36. The temperature sensor has a chip that tells you what the ambient temperature is. Use the fact that temperature increases, the voltage across a diode increases at a known rate. The voltage put out is proportional to the ambient temperature. Building the rocket. The rocket used for this project is modified SD's Big Daddy rocket. Modify the nose cone to accommodate the payload. Will launch using an E24W engine by Aerotech to support a launch of 1,000 feet. And the rocket will be painted before launch as well for preparation. Data observations to be collected. Hopes to launch with the Southeast Alabama Rocketry Society to collect data. New skills learned: soldering and associated troubleshooting, working with a multimeter, stripping wire. Troubleshooting: checking that all need and update libraries are installed, checking soldering joints, continuity, checking voltage on proto board, checking continuity of wires, checking FDTI cable, current drivers. Useful tools: solder sucker, solder removal tape, rocket computer program, RockSim by Apogee. Design any size rocket and simulate its flight. References. And thank you to Dr. Kaminsky, Mr. John, and Mr. Alcacer for your support on this project.
Well, thank you, Benjamin. That was just great.